Good morning everyone, myself Syed Muskan and my topic is black body radiation. Till now we have seen how light exhibits the properties of electromagnetic waves. On further study of nature of light, we have seen that the light does not behave as a wave. In some cases, it behaves as a particle. There are two properties which confirms that light behaves as a particle. The first one is black body radiation and the second one is the photoelectric effect. Now before going to the black body radiation, we will see how light interacts with the matter. Now let us consider the matter on which the white light or the light radiations which are incident. Now as you know, the white light consists of many radiations of different wavelength. Let us consider the wavelength, that is lambda 1, lambda 2 and lambda 3. This is white light. This is matter. The white light have the many radiations having the different wavelengths are incident on the matter. Now here the three properties takes place or the three phenomena takes place. The first one is some light get absorbed. Few radiations get absorbed, then few radiations will get reflected and few radiations will get transmitted. Now what I have done, the white light, it consists of many radiations of different wavelength are incident on the matter. Now after incident on the matter, there will be takes place three properties or three phenomena will take place. The first one will be absorption, reflection and transmission. Now the few radiations which are get absorbed by the matter, the few radiations which are get reflected by the matter and few radiations which will get transmitted by the matter. The reflected rays which are reflected, will give the color of that matter. For example, the light is incident on me. The light is incident on my clothes. So you are going to see or you are seeing now the color of my cloth or color of my coat is blue color. Why so you are seeing the blue color only? Because the radiations which are being reflected from me or from the coat is the wavelength of that blue color. The maximum amount of radiations which are being reflected is of the blue color wavelength. So you are seeing the color of my coat, that is blue. Similarly, when these radiations will get reflected, the radiations which will get reflected will show the color of or which will give the color of the matter. Similarly, in our surrounding, why we see the particular color, there is a reason behind it. That is, the radiations which are reflected, that reflected radiations have the particular wavelength of that color and you will see the particular color. Now let us see what will happen when this matter is get heated. When the heat is applied to this matter, then it emits all the type of radiations. All the type of radiations means what? It will emit the radiations. When the radiations are emitted, it will not emit just one particular radiations of the particular wavelength. It will emit all the types of wavelength of the different wavelength of the radiations. For example, lambda 1, lambda 2 and lambda 3 and so on. Many radiations are emitted. When we heat the particular matter by the heat source, then it emits all the type of radiations of different wavelength. But the difference is only one. What is that? The particular amount wavelength is some amount of wavelength will emitted in small quantity, while some of the wavelengths will emitted in the large quantity. The quantity or the wavelengths which are emitted in the large quantity will decide the color of the matter. For example, metal rod. For particular temperature, the color of the metal rod is reddish. Why it is reddish? Because at that particular temperature, the color which is being emitted is the wavelength of the color of the red. So we are going to see the color reddish. On further increase in temperature, the red color turns into blue. Means at that instant the wavelength which is been emitted, or the light which is been emitted means what? The light which is been reflected from that particular metal is going to be of blue color wavelength. That is, the blue color wavelength should be present, but the wavelength, the amount of that wavelength or the radiation should be maximum. The amount of radiations which are being incident on it. It does not reflect any amount of radiation through it. That means, similarly, we have heated the matter. Similarly, if we heat the black body, the same graph is being observed that as the intensity is less, the wavelength will be less. At particular instant, the wavelength will be maximum. That means lambda max. This will be lambda max. This is the experimental. We perform the experiment and we have seen that the lambda will be, if the lambda is less, then the intensity or that particular wavelength for that lambda, the intensity will be low. At particular instant, the lambda become max, and the maximum intensity means what? This lambda max will be emitted, or the particular wavelength of that radiation will emit in the more quantity. Later again the lambda increases, but the intensity goes on decreasing. That means at this instant will confirms the color of that particular matter or that body. But later, what is observed that the theoretical graph is given by this. This is theoretical graph. Now you are going to see that, now you can observe that at particular instant we can see that the graph is in the similar manner, which shows the similar properties. But you can see that there is a vast difference between these. What we have observed that for the less lambda, that means for the radiations which are of less wavelength will be emitted in the small quantity, which is being observed. But the theoretical graph says that for the less lambda, means the radiations which are of less wavelength will be emitted in the large quantity. So this is the there is a lot of difference between the graph which is observed by the experiment and the theoretical. That means it confirms this theoretical graph is given by considering that the light is obeying the wave nature. But after observing, we can conclude, or we can say that light does not behave only as a wave, but sometimes it behaves as a particle. So we can confirm, or we can say that this is the property, black body radiation is the property which confirms or which tells that light does not behave as a wave, but also it behaves as a particle. Thank you.